up till this point, we've only solved equations that have one variable, and therefore there's one solution. It's the solution, or some of them have no solution or identities, but the solution is the number that you plug into an equation to make it true. Well, now we're going to have equations in two variables. They look like this: 4x plus 3y equals 10. A solution would need to have both an x and a y that would make it true. So if I plug in, for example, 4 times 4 plus 3 times negative 2, it does make it true, because 16 plus negative 6 is equal to 10. That means that, and we write these as an ordered pair, 4 negative 2. And as I'm sure you've probably jumped to, like, oh yes, I've seen ordered pairs. That has to do with the coordinate plane. Here's another solution: 4 times negative 2 plus 3 times 6, because negative 8 plus 18 equals 10. So that is true, meaning that negative 2 for x and positive 6 for y is a solution. Here points out something right away that's really true. There's not one solution. There are actually an infinite number of solutions to this, because if I make the x a different number, I can just find a different y that fits it in. So now we have things that equations have an infinite number of solutions. In other words, I can just keep plugging in different things to make them true. When we go on to graph these things, we are going to be using the coordinate plane. So in your homework, there is one side of the sheet that is all about the vocab and the whole idea of these. For that, I want you to actually read pages 353 to 354 to really start getting the idea. But if we think about our other equation that we talked about a minute ago, which was 4x plus 3y equals 10, we could think of these. It's sort of like a function machine. If I plug in 4 for x, the other number that came out was negative 2. When I plugged in negative 2 for x, the number that came out was 6. So part of your homework is looking at what are essentially function machines, doing the math by evaluating for different numbers of x, and then going to your coordinate plane and graphing them. I'm only going to be estimating, obviously, so 1, 2, 3, 4, and then down 2. So this is the point 4, negative 2. And the point negative 2, 1, 2, 1, 1, 2, 3, 4, 5, 6 is up here. And you will find that the graph of equations in this form, where there are no exponents for the x or the y, and you're not dividing by the variable, but we'll be talking about forms of these equations. When you graph them, they actually come out to be a straight line. If I had a third solution here, I would be able to. Okay, I can't really draw straight lines using a ruler with this, so I'm just going to have to estimate. But I will ask you to please, whenever you're graphing, always use a ruler, because accuracy will help you here. This is a picture, actually, of all of the solutions. Any point on this line, if I was able to accurately look at its coordinates, would be a solution to this equation. When I plugged it in, it would equal 10. So one of the big ideas that I will be driving home to you all the time, this line, any point on the line is a solution to the equation, and every solution to the equation is a point on the line. Your first function machine looks like this. The first on the page 7.5. We have x and we have y. The equation is y equals, and don't forget this means the opposite of x, minus 3. You might want to include the negative 1 here for that, but here, when x is 4, the opposite of x would be negative 4 minus 3, and that equals negative 7. So when x is 4, y is negative 7. The next one, when I plug in negative 1, the opposite of negative 1 is positive 1. Minus 3 is negative 2. So when x is negative 1, y is negative 2. The next one is negative 6. The opposite of negative 6 is positive 6. Minus 3 is 3. And finally, if we were playing the function game, this is the one you would have done first. 0 minus 3 is negative 3. They give you a graph. Again, I'm not able to really do these. I'm going to have to figure out how to fix that problem as we do this unit. But we've got 4, negative 7. I'm not going to be able to fit it. 2, 3, 4, 5, 6, 7, so we're down here. We've got negative 1, positive 2 is about here. Negative 6, positive 3 is about here. So you get the idea of this line. 0, we said, was negative 3, so we know it's crossing here. And when you graph these points on this thing, if your equation was exactly right, I think I graphed. Oh, this point is wrong. My eraser is not working. This should be negative 1, negative 2. Okay, now my pencil isn't working. Negative 1, negative 2. So we've got here. We've got negative 1, negative 2 here. We've got 0, negative 3 here. I need to make this point go away. It's not going away. Anyway, and then negative 6, 3 is out here. So your line goes essentially like that. So in your homework, you just need to plug things in and not make mistakes like that. Just graph your points. Hopefully you remember the coordinate plane. This is just the beginning of a long unit of cool stuff that we're doing with equations in 2 variables.